This is Mr. Walters and welcome to AP Chemistry Online. What I want to do today is review a little bit Ka, Kb, but we want to talk also about the common ion effect. We want to talk about buffers, but we want to talk about buffers on a more quantitative level as opposed to a qualitative level. I also will be reviewing several aspects of acidic-base salts, etc., just to make sure we got a firm grasp on that before we move on. Anyway, here we are. We've got an acidic acid solution, and notice the molarity is 0.50 big M. So let's take a look at the Ka expression for that. Nothing new here, just good kind of review. So let's go Ka equals concentration and notice the Ka value is 1.6 times 10 to the negative fifth. So that obviously is a weak acid. Let's do an ice problem to figure out, remember ice, proud papa here, love my, my kids, my AP Chemistry kids, proud papa doing an ice problem. So let's say we've got our molarity here. Let's say we want to determine the pH of the solution. So let's do that. Here's our equilibrium situation. So let me erase just a little bit here and we'll do our ice problem. Notice we have initial change in equilibrium, and we're going to start off with 0.50 big M solution here. So 0.50 big M solution. Initially we have no acid, no conjugate base there. We're going to get a change here that's going to decrease by a factor of x. This is going to increase by x. This is going to increase by x. And at equilibrium, we're going to have 0.50 big M minus x, and x. Let's take these equilibrium values and plug them into the Ka expression, and we'll see what we get. So we have x 0.50 big M minus x equals 1.6 times 10 to the negative fifth. So let's go ahead and we're going to calculate the x concentration. But before we go on, let's assume that this value is negligible because we've got a small Ka value here, and we have a large concentration here at 0.50. So let's just assume that this is negligible, make the math much more easy, and then let's solve for x.